Welcome to your Algebra 2 lesson, 4.9, Graph and Solve Quadratic Inequalities. No surprise, the objective today is to graph and solve quadratic inequalities. So a quadratic inequality in two variables is any inequality that can be written in any of the following forms. Y less than ax squared plus bx plus c, or y less than or equal to ax squared plus bx plus c, y greater than ax squared plus bx plus c, or y greater than or equal to ax squared plus bx plus c. To graph a quadratic inequality, follow these steps. The first step is to graph the parabola with the equation y equals ax squared plus bx plus c. Make the parabola dashed for inequalities with less than or greater than, and solid for inequalities with greater than or equal to or less than or equal to. So it's just like with lines. The rules are greater than, less than, dashed, greater than or equal to, less than or equal to, solid. Test a point xy inside the parabola to determine whether the point is a solution of the inequality, and then shade the region inside the parabola if the point from step 2 is a solution, if you get a true statement, and shade the region outside the parabola if it's not a solution, if you get a false statement. Okay, so we're going to graph y greater than x squared plus 3x minus 4, and we've got a picture over there, so how do we get to that? Well, the first thing we do is we graph the parabola. So we're going to graph y equals x squared plus 3x minus 4. And because the inequality symbol is greater than, make the parabola dash. Now, if you need to go back and look at the video from 4.1 on how to graph y equals x squared plus 3x minus 4, that's fine. Remember, you want to find the vertex and then make a table of values centered around the vertex, and that will let you graph the parabola. You can also start with the vertex and then put it in intercept form. Write it as y equals x plus 4 times x minus 1 and find the x-intercepts at 1 and negative 4. You can see those are on there. There's lots of ways you can get that parabola graphed. Okay, step 2, we're going to pick a point inside the parabola. So 0, 0 is inside it, so that works great as a test point, and we'll put it in our inequality statement, substituting 0 for y and 0 for x. So 0 is greater than negative 4. That's true, so we shade inside the parabola. So you shade the region inside the parabola, and you get the picture we see here. Okay, if we'd gotten a false statement, we would shade that region outside the parabola. Let's look at an example. Let's look at rappelling. A manila rope used for rappelling down a cliff can safely support a weight in pounds provided that the weight is less than or equal to 1,480 times d squared, where d is the rope's diameter in inches. Graph the inequality. Okay, we're going to graph W equals 1,480 d squared for non-negative values of d. Well, why non-negative values? Well, a diameter can't be negative, so anything with a negative diameter wouldn't make sense. So we're going to use non-negative values of d. We'll start at 0 and go bigger. Because the inequality is less than or equal to, make the parabola solid. Test a point inside the parabola, such as 1, 2,000. So to graph this parabola, I would make a table and start with 0, 1, 2, and actually figure out the point. So I would plug in 0 and get that W is equal to 0. I might plug in 0.5. If you plug in 0.5, you get a value of 370. If you plug in 1, you get a value of 1,480. 1.5, you get a value of 3,330, and then 2, you get a value of 5,920. So it would be way up here at 2. And so here's our little parabola. Okay, so we might test a point like 1, 2,000. So when you put in 2,000 for the weight and 1 for d, you get 2,000 less than or equal to 1,480 times 1 squared. 1 squared is just 1, so we get 2,000 less than or equal to 1,480, that's false. So we don't shade inside where the 1, 2,000 is, we shade outside here. Because 1, 2,000 is not a solution, shade the region below the parabola. Okay, shade the region that's not inside the parabola. All right, we are going to come back and actually let's look at one example of graphing a system of quadratic inequalities, and for that you're going to graph each individual inequality on the same coordinate plane, and then you're going to identify the region where the shading overlaps. This region is called the graph of the system, or the solution to the system. Okay, so our first inequality statement is y less than or equal to negative x squared plus 4. So that's going to be a solid parabola. Let's see, the parabola itself will be open downward. I know that because a is negative. It's going to have a y-intercept at 4. There's lots of things I can see immediately. My second inequality is y greater than, so it's going to be dashed, x squared, so it's going to open up, minus 2x minus 3. There's inequality 2. So for our solution, the first step is going to be to graph the first inequality statement. So we're going to graph y less than or equal to negative x squared plus 4. The graph is going to be the red region inside and including the parabola y equals negative x squared plus 4. Again, I refer you back to the videos or look in your book at section 4.1 for how to graph a parabola in standard form. So here we've got y equals negative x squared plus 4 is the solid parabola there, and then if you test 0, 0, 0 is less than 0, negative 0 squared plus 4, that's true, so you shade inside here. So this red parabola is the first one. The blue parabola is the second one, and since it's strictly greater than, you are going to have a dotted parabola, so you can see it's dotted. Again, if you plug in 0, 0, you get 0 greater than 0 minus 0 minus 3, so 0 greater than negative 3, that's true, so you're going to shade inside the parabola here. So our final solution is this purplish region where there's overlap. Okay, identify the purple region where the two graphs overlap. This region is the graph of the system. Okay, that's it for video 1. We're going to come back with video 2 and talk about solving a quadratic inequality in one variable algebraically.